Okay, page 89. What I would suggest that you guys do in your notebooks is turn it sideways. Okay, turn it sideways. What we're going to be doing is we're going to be drawing a graph. Okay, we're going to be drawing a graph, and so it's better if it can take up a little bit more space for your labeling purposes. Okay, so turn your notebook sideways. This is going to be what is called a landscape graph. If you would like to get a ruler for straight line purposes, you're more than welcome to do that. What we're going to be doing on page 89 is we are going to be drawing what is called the heat curve of water. Okay, heat curve of water. I am still hard of hearing in my right ear. It's still very hazy over here. So if you say something and I don't hear you, it's just because I don't hear you. It is, again, not because I'm ignoring you. I had about 2 minutes yesterday of dual auditory canal hearing. It was wonderful. 1 minute left. So here's our graph. The whole page is fine. Leave a little bit of room on the side for labeling your y-axis. All right, on Monday, when you guys had, last Monday, when you guys had Mr. Stocking and you guys did the solid, liquid, gas cards, you guys looked at the characteristics of solids and how they compared to the characteristics of liquids and gases at the end. So, for example, if you looked at the movement energy of your particles in a solid, they have very little, almost no movement energy, correct? Then if you go to the liquid side, they have a little bit more energy. They're moving around a little bit more. And then your gases have a lot of movement energy. Okay, so what we're going to do today is how do you take that solid particle and how do you turn it into a liquid? Okay, and then how do you take that liquid and turn it into a solid? So our graph is going to take on a certain shape. I'm going to try to do my best to make it as realistic as possible. There is going to be an incline on our graph, a very short incline. And then once it reaches a certain point, it's going to form a flat section. It's what I call a plateau. Okay. It's going to sit at a plateau for a while, and then it's going to form another incline. This is the shape that a heat curve takes on. This incline tends to be a little bit bigger than the first one. Once it reaches a certain point, it's going to flatten out again. And you have your last incline. Make them as parallel as possible. Okay. So this is the shape of a heat curve. As the name suggests, we are going to be looking at temperature changes as a heat curve. So on the y-axis, we are going to label that our temperature. Okay, and that unit is going to be in degrees Celsius. Remember, we don't use Fahrenheit in science. Okay, so if our temperature is here on our y-axis, down here we have very low temperatures. What state of matter do you guys know is present at low temperatures? Solids. Okay, so this is where we're going to go ahead and label our solid material. So for water, this is where you have ice. Okay, this second plateau, you have a little bit warmer water. So what state of matter is here? This is going to be where you have your liquid. And then at this high temperature up here, this is where you're going to have what state of matter? This is where you have gases. All right, you guys know from experience, if you want to move from a solid to a liquid, what is that phase change called? Remember, you have to speak up. It is a physical change, absolutely, but what is the actual process? If you take an ice cube and put it on the sidewalk on a hot day, what does it do? It melts, okay? So this phase change, as you go from solid to liquid, is called melting. Okay? Now, while your ice cube is sitting on the sidewalk, what states of matter are present? Solid and liquid, okay? Both states of matter in that transitional period are present. So, at melting, you have solid and you have liquid states of matter. Both would be present on those phase changes. Okay? Now, once all of your solid has melted and you're left with just liquid, what's going to happen is the temperature of that liquid is going to increase if you continue to apply heat. So your temperature of your liquid increases until it gets to this phase change. What is the phase change from liquid to gas called? Evaporation. Now I am going to change it just a little bit for our graph. We're going to change it to vaporization. Okay. Vaporization, going from a liquid to a gas. All right, now during the vaporization stage, okay, think of a boiling pot of water. What states of matter are present? This is liquid and gases. Both of them are going to be present at this stage. Now, if you had a gas collection chamber above wherever you are evaporating your liquid from, it could collect that gas, and then your gas would continue to increase in temperature to a certain point, and then eventually it would become plasma if it has enough energy. It's really hard to get to the plasma stage though. So, not very common. We will not be dealing with plasma in this class. All right? Solid to gas. Does anybody remember maybe from middle school what that process is called if you go straight from a solid to a gas? Dry ice does this. Maybe when you learned about dry ice. Okay, this is called sublimation. If someone said it, I'm sorry I didn't hear it. Okay, if you go from a solid to a gas, completely bypassing the liquid stage, that is called sublimation. You guys will see a lot of this second semester when we start talking about gases and gas laws. We'll do a lot of labs with dry ice. Okay. All right. If you're going from a solid to a liquid, what do you have to do to your particles? You have to get them moving, right? You have to get their movement energy up. How do you get them to start moving? You add heat, okay? So you have to add heat or you have to add energy to your particles. Any phase change in this direction, from solid to liquid to gas, has a name. Okay, we call these processes endothermic. Okay, these are called endothermic processes. Now the prefix endo, just like it sounds, is into. Thermic means heat. So in these processes, you have heat going into your particles. Heat is being absorbed. Alright, so what if we want to go in the opposite direction? What if we have a gas and we want it to become a liquid? Does anybody remember what that process is called? It is going to be exothermic, absolutely, but before we get to that, just the general phase change is called what? Condensation. Okay, condensation. You have a cold soda can on your counter, and you start to see those little beads of water forming on the outside. That water is called condensation because it's taking the water from the air, cooling it down, and it becomes a liquid. All right, so there's your condensation. Once all of your gas has condensed down, it becomes a liquid. You can continue cooling that temperature until it starts to do what? What would this phase change between liquid and solid be? This is freezing. Okay. Going from a liquid to a solid is called freezing. Okay, now this is the one that students tend not to remember from middle school. Okay, if you go from a gas to a solid, the name of that phase change is deposition. Okay, deposition. All right. As someone mentioned earlier, if you are moving in this direction from high temperatures down to low temperatures on the graph, these are called exothermic processes. Which means that you have to cool them down, you have to remove energy from your particles. Heat is released. Now, specifically, we said this heat current is one of water. So knowing what you know about water, we know that solid ice is going to melt at what temperature? What is the melting point of water? 0 degrees Celsius. Okay, so if this is specifically for water, we would be able to look at this point on our y-axis and say that this is 0 degrees Celsius. Okay, and we know that because this is the melting point of water. Okay. We can also look at this point on our graph, okay, where your liquid water starts to turn into gas or steam. And we know that water boils at what temperature? 100 degrees Celsius. And we know that because that is the boiling point of water. Questions on this graph? Okay, it's pretty straightforward. What we're going to be doing for this unit is you guys are just going to be responsible for labeling it and understanding what's happening solid, liquid, gas-wise at each point on the graph. In the future, when we start talking about energy changes, you guys are going to be using this graph to actually calculate the amount of energy